So in this video, we're going to have a look at linear equations and linear equations on graphs. We're going to explore how we can find the gradient of a line equation when we have just 2 points. We're going to look at how we can use the point-slope formula to derive a linear equation in slope-intercept form with just one of these points and the gradient. And lastly, we're going to look at how we can compare multiple linear equations to see if they're parallel or perpendicular to one another. Now let's have a closer look at these 2 points on this graph here. If we want to fit a line between these 2 points, a straight line, we would need to divide this vertical distance here by the horizontal distance. So our points are 6 and 6 and 2 and -3. Now it doesn't matter which way round the y1 and y2 is, or the x2 and x1 is, we'll still end up with the same gradient. So for y2 we have -3 minus y1, which is 6, divided by x2, which is 2, minus x1, which is 6. So our gradient becomes -9 divided by -4, which equals 9/4. In other words, for every 4 points that this line moves on the x-axis, it moves up 9 points on the y-axis. So with this information, how can we generate a line equation in the form of y equals mx plus b? Well, for this example, we'll use the point-slope formula down here. We've worked out the gradient already, which is 9/4. And we can choose one of these points up here to act as our x1 and y1. So initially, our x1 and y1 was this point up here, but we can quite easily choose this point's coordinates as our y1 and x1. So we have y minus y1, which is -3, is equal to our gradient, which is 9/4, multiplied by x minus x1, which is 2. So we have y plus 3 is equal to 9/4 multiplied by x minus 9/4 multiplied by 8/4. We get y equals 9/4x minus 4.5 minus 3, which is -7.5. Now our linear equation here has a positive gradient, which we can see on our graph here, and the y-intercept crosses the y-axis at -7.5, which we can see here. So how can we determine whether our linear equations are parallel or perpendicular to one another? So let's first look at equations that are parallel. So if we have a look at these 4 linear equations here, are there any linear equations here that are parallel to this equation? Well, when we have parallel lines, their gradients should be the same, like these 2 lines here, but their y-intercept can be different. So out of these 4 linear equations here, can you match these lines with one of these equations? Well, we know that our gradient, m, has to equal 2.25 or 9/4 to match this gradient here. So we can cross out this equation and this equation, because this equation has a -2.25. The next thing we do is look at the y-intercept. So we've got a -3 for this equation here, which means that this line that crosses the y-axis at -3 matches this equation. And this equation has a value of 0 for its y-intercept, which matches this line here. Now, lines that are perpendicular to our linear equation here will intercept this line at a 90-degree angle. And this means that the slope of this line here is the negative reciprocal of this slope. So what this actually means is when these two lines are perpendicular to one another, these two linear equations, the product of both their gradients, so m1 multiplied by m2, will equal -1. So you can imagine that this gradient here is our m1, so 2.25, and this gradient here, which is perpendicular, is m2, and that equals -1. So if we rearrange this to make m2 the subject of the equation, we've got m2 is equal to -1 divided by 2.25. So our gradient here should fall in value by value of 4 for every 9 squares we move in the positive x direction. And we can see this on the graph here. So if we go down by 4 spaces, we have to move across 9 spaces to intercept. -4 plus 9. And because our line equation intercepts the y-axis at 7, our equation for this line becomes y equals -4 over 9x plus 7.